कलर ओवर कर दो, कलर टोन दो जो खाली।
Hello friends, good evening. Why is it not coming properly? Good evening. Good evening. Thank you. So friends, once again we welcome you all to this UltraTech knowledge series, which is jointly organized by Knowledge Studio and UltraTech Cement Limited. So once again, thank you. And today is our lecture number 4, and the topic is in transit concrete, which is being conducted by our today's expert, Engineer Keval Ashe. So before we proceed ahead, I would like to invite all our interviews to on the dais. So I would like to invite Sri Narendra Patel sir, as well as Sri Chaitanya Sangvi sir, as well as our regional technical head, North Gujarat, Sri Nitin Chaudhary, as well as our today's expert, Sri Keval Ashe. Please.
कवर पेज में लगी नहीं हो रहा पची करो।
So, as tribute to our soldiers, we will start with national anthem. I will request to all of you to join us for national anthem.
हाँ अगर प्रोग्राम चालू है
So now we will felicitate our today's guest of honors. So first we will felicitate our today's guest of honor, Sri Narendra Patel sir, and I will request Sri Nitesh Shah sir to felicitate Sri Narendra Patel. Thank you, sir. And we have also our today's guest of honor, Sri Chaitanya Dr. Chaitanya Sangvi sir. So I will request Murji Prajapati as well as Vikram Kamboya from UltraTech. So now we are very eager to hear our today's guest of honor, Sri Chaitanya Sangvi sir, as well as I am also feeling honor that I am student of his batch. I am from pass out early from 2010 batch. So I am feeling pleasure to introduce Sri Chaitanya Servicer. So Major Dr. Chaitanya Servicer, he has 31 years of vast experience in this academic career. He is head and professor at Agri College of Engineering. Before that, as well as he has completed his PhD in earthquake engineering from SeriesLecture Surat in 2013. Apart from that, he is also involved in all the academic curriculum activities as well as that technical paper presented. More than 70 papers are been shared, presented to international, national conferences, as well as work as resources person structure in earthquake engineering. There are I can say there's a vast experience in this curriculum activity as well as the activities are being conducted at college level also. So he is also associated in social services like blood donation, as well as he is the first Indian officer with the rank of major become a centurion blood donor. So now I will request Sri Chaitanya Servicer to share his kind words. Thank you.
Very good evening to one and all. It is my pleasure to be a part of this lecture series, and I also completed Untitled Cement and Untitled for organizing such a nice lecture series which will enhance your knowledge. You see, today we are talking about the career as a student. What exactly we are expecting in future is very important. So today, I'm not going to talk about any technical things, but I'm going to share my experience, my life experience, and what, after 31 years of my experience, I feel that what exactly I have conceived in my mind long time, almost I achieved most of the things, right? So you have to be desperate for your dreams, and you must have a passion. If you have a passion, definitely you will achieve your goals. Right? So when I was studying, I'll tell you that I want to become a army officer. Right? That was my first dream, and basically I'm from Gujarati family, and as far as Gujarati family is concerned, you never believe or you never want to enter in armed forces, right? So the same environment we have in our family, and then the family members are saying that don't enter into the armed forces, but it was my deep desire. So because of many reasons, I was not able to enter into Indian armed forces. The another part was that I want to become a doctor also. And after the 12th admission, percentage was good enough, so I was getting admission in Jamnagar Medical College, the first admission in Jamnagar Medical College. And but because of our financial condition at that moment, again I'm not able to enter into that particular field. So the most desired things what I want to do, I was not able to do. And my third goal is to become a civil engineer because I love buildings, and therefore, even though I'm getting the admission in electronics communication at that moment, the higher branches also, but still at that moment we have a common admission in medical and engineering. So at that moment we have to fill the choice. So both the admission taken place simultaneously. So in a one room, either you want to enter into medical or engineering. So I opted for only single choice, that is Ahmedabad Civil. Ahmedabad Civil is LD college. I'm getting the admission, and I was admitted in civil engineering branch at every college that we did. Only choice I tell you. I'm not written anything else in my choice form. Ahmedabad Civil, that's all. I'm getting that, and when I'm returning back to my home, my friends are saying that okay, when did you get admission? I said Ahmedabad Civil. So they feel that I got admission in Ahmedabad Civil means medical college. And for 2-3 years they will remain in suspense, and later on it was like that I entered into the ND college and in the CDG branch. So what I want to say is that don't, as far as your choice of career is concerned, don't limit it to one option. Keep 2-3 options. So that will not depress you in future academy, right? And select those 2-3 options which you like actually, right? When you married a woman and you don't like it, then your life will become hell, right? Same way, when you are serving for maybe 30, 40, 50 years, right? And you are selecting a branch or selecting a field which is not of your liking, definitely you will not work with the full enthusiasm, right? So this is my request to all of you, that when you select, like, okay, I want to do bridge engineering, I want to do software engineering, don't confine yourself to that, but give a wide opening as far as choices are concerned, right? So that is the first thing. Now, second, what I want to say is that, you see, I desire to enter into armed forces. I didn't get the opportunity to enter into armed forces, but I got the opportunity to enter into armed forces indirectly. In 1998, my principal told me that, okay, you will be now in charge of NCC. So at that moment, I was handling sports, I was handling cultural activities and other activities in the campus. So I was little angry that why you are giving me so much portfolio. And the order was there in the month of March, and I didn't join NCC at that moment. And in the month of August, when NCC parade started, when I was entering into the campus, I see the 200 cadets are doing the drill. Right? They were doing drill, and it was amazing. And then I feel that, okay, this work is close to my heart, and why should I join? And then I joined NCC, and then I took the army training. Thrice, 3 times I took the army training of 3 months. Right? And gradually the same rank, like lieutenant, then captain, and then major. So those ranks were achieved. But basically, I want to work with Indian Armed Forces, and right now I'm working with the Indian Armed Forces for the last 24 years. Right? So my first dream was completed indirectly. Right? So this is the most beautiful, I tell you. You see, I was always believing that I was not able to achieve my dream. But you see, indirectly, the life will give you the opportunity to achieve your dreams. Right? But you must have a strong desire. Then and then you will achieve your dreams. And then comes the way that I want to enter into the way, like I want to become a doctor. Doctor, not to earn money, not to earn money. Why I'm saying this? Because when I entered into civil engineering, and sir, I tell you that after graduation, I joined a master's program, and my uncle was asking me, why you join master's program? Because we have a big company, Sanjeev Construction in South, and they are doing a lot of work of the Indian Army, Air Force, hangars and everything. I think Sanjeev Construction has a dominance on that. And then I said that, okay, I want to do my structural engineering, and then I will decide what to do. And by the time, after 1 year, I got the opportunity to join as a lecturer in Government Engineering College, any college mostly. I got the appointment. I completed my 1 year of post-graduation, and I have completed my dissertation. So I feel that, okay, I will get the salary of 33,100 at that moment, and I will complete my dissertation also. So I joined that, and you won't believe, when I joined that, I was not able to complete my dissertation within 6 months. It took 1 year, 1.5 years to complete my dissertation, but I started learning this particular job as a professor. Right? So then again I met my uncle. My uncle was saying that what are you doing there? I'm working as a lecturer in government college, and he got involved. So he said, why are you joining this? Then I said, I like this job. Then he said that whatever you earn during your whole career, you will earn in a single year in this construction business. And you know that. We know that it is quite true, right? But basically, you see, I want to work in this area. I continue with this. I am highly satisfied. You see, I am blessed that I am one of the persons from the government who is fully satisfied while working in this government sector. This is really amazing, I tell you. We have a lot of constraints, but within this constraint, we worked a lot, and I think so. You see, now my second dream was to work as a doctor, to serve the society, right? And I joined with the Indian Red Cross Society, and with the Indian Red Cross Society, we worked a lot in the field of blood donation, thalassemia, stem cell donation, and many other fields, I tell you. And during the corona, we worked a lot. When the lockdown was there, almost my NSS volunteers were not there in their homes. They are serving on ground for the 2.5 months, and they have distributed the food kits. They work with they are giving the oxygen concentrators and many things. So you see, indirectly I completed my second dream of serving the society, right? So all the three dreams, they come alive, and right now I'm working in all the three areas. And particularly, I want to work in the area of earthquake engineering. And I got the opportunity in 2003, where I took the special training at IIT Kanpur, and there is a 1 semester long training program in the earthquake resistant design. So the basic thing I want to tell you is that don't suppress your desire. You must have a strong desire. Keep this desire in your heart, in your mind. Write down those your goals, and definitely you will achieve that. Right? This is for sure, I tell you. And you will definitely achieve this, right? But you must have a strong desire. Right? The second thing I want to tell you is that is regarding you are in the college, right? Yes or no? Yes, sir. So you feel that? So how many of you are attending full classes? That's wonderful. How many of you are also participating in co-curricular activities, extracurricular activities? Right. So always I'm saying that when you are in the college, the study is very important. Academics is very important. It is good for your profession, right? For your professional career. If you study well, definitely you will have a better future. But at the same time, suppose if you miss your enjoyment in the campus, the life in the college campus is something different, right? The enjoyment is very important, and if you have not enjoyed the campus life, definitely you will remember for the lifetime that I missed my college life, and you will never get it back. So along with the academics, always enjoy your college life. I don't mean that only enjoy college. Definitely you will remember your college life. If you have only enjoyed, your professional career will be, it is not good for your professional career, right? You will remember for the lifetime that I have done nothing as far as academics is concerned. But the mantra is study as much as you can, and at the same time enjoy as much as you can. These 4 years are very precious to you. Remember, these 4 years are very precious to you. તમે સેલિબ્રેટ કરશો, એન્જોય નહીં કરો, ત્યાં સુધી તમને મજા નહીં આવે. So don't miss this opportunity. Enjoy college life fully. Once you enter into the professional career, then it will be very difficult for you to take some time for the enjoyment. Right? It's very difficult. Right? So definitely you get a good, suppose you get a good job, like good job, so you earn a good amount of money, right? Because you are studying and you are studying for getting a job. And why do you want jobs? Because you have some family responsibilities, and that is supposed to be fulfilled. That's fine, right? So you get a good job. Then during your professional career, you have a lot of stress, right? Because you have to achieve your goals, you have to achieve your targets. Those will be there, and you will be fully stressed. So at that moment, what you want a hobby of your liking, right? That will make you relax, right? For music, for example, if I hear music and I get relaxed, fine. If I love dance, I perform dance, it's better, right? I'm giving you an example of my daughter. My daughter is studying right now. She's an architect and she is working from 9 to 6, right? And then 6 to 9, again she go for the dance practice, right? Right now she's studying, and when she's at home, when I'm asking that, okay, do this work, she says, I'm tired. But when she is going for the dance, she never get tired, I tell you, because it is her hobby. So that's why I'm saying that you must have a single hobby which will keep you relaxed throughout the life, right? And then the third important thing is you have to be physically fit, right? And I tell you that during your life, your physical thing will getting disturbed with the age, right? So you must have at least one sport in your life, right? So keep one sport in your life, and that sport will make you happy and fit. And you see, you are doing job, you are hearing music, or you are enjoying your hobby, you are going for the sports. Everything is for you. And the last thing I want to tell you is that you have not done anything for the society, right? So this society has given you a lot, and then you have to think about what I can give back to the society. This is very important, right? So you have to think about your social responsibility. Social responsibility means what I can give back. You see, it will be a very small thing. What I feel is that I believe that I have to give it back. So what I started the blood donation in my college life, right? And every 3 months I donate blood. Every 3 months, right? So by donating a single bottle of blood, you are saving 4 lives, right? Now just imagine, as an engineer, if I save 4 lives, nothing is better than this, right? And even I'm serving the society in that case. So how much time you need for the blood donation? Hardly 30 minutes, 1 hour. So in 3 months, if you spend 1 hour, that's fine. Yeah, I'm not saying the only blood donation. You can have your own choice. But that choice must be consistent. You say, okay, I want to spend 2 hours per week, 2 hours per month, or 6 hours per month, whatever it may be. But decide those things and just working on that, right? So that will make you happy from within, I tell you, right? Inner happiness will be there. When you see the smile on the face of somebody, right, then definitely you will love it, right? So you must have to understand your social responsibility and go to work on that, right? So I'm not going to take more, but thank you very much for giving me the opportunity to share my experience. I'm not going to share my practical experience right now, but I just share my personal experience. And I think here the whole young generation we have, and you are the future of the nation. So you are carrying a lot of responsibility on your shoulder. Remember, right? The nation is expecting many such things from you. So contribute. That's all, right? So thank you, UltraTech Cement and Hackathon for inviting me here for interaction with you. Thank you very much.
So sir, thank you for sharing your motivational speech to us, and just we can say give us some mantras. As Suresh told, study as well as you can your hobby, your fitness, which will be helpful to you for your journey as well as for your professional journey in the future. So now we have also our today's another guest of honor, Shri Narendra Patel Sir. So he is right now he is chairman of Nardeco, as well as he is chief managing director of Sun Builders, as well as his work experience. He has vast 4 decades of experience in this our civil engineering field. He has worked for 17 years with with ODA, Ahmedabad Urban Development Authority, as well as we can say his real estate business experience for more than 4 decades. And there are so many posts have been held by sir. So chairman of Nardeco, president of India, president of Institute of Town Planners of India, New Delhi, between 2020 to 2021, member of Appeal Committee, GDCR. So there are so many posts have been held by sir, as well as there are so many publications on urban development and housing for various state and national journals. So there are so many activities also, sir is also associated with us. So now I will request Sri Narendra Patel sir to share his kind words. Thank you, sir.
Good evening. First of all, thanks UltraTech and Knowledge Studio for arranging a very unique knowledge series. You are just on a verge of completing your civil engineering. And at that time, in all 6 lectures, there will be 6 excellent technical lectures also will be there. And in each lecture, a civil engineer with some difference, we are calling, and you are getting some tips for a future career. I'm Narendra Patel. I did my civil engineering from IBA College of Engineering. I did my law. Then I did my master's in urban and regional planning from SET. I am from a town which is something 100 kilometers away from Ahmedabad. I started studying English at the start, at the 8th standard. So today, in junior KG or playgroup ABCD has been taught or learned by the kids. It has been taught at that time in that system at the 8th standard. I got the admission in MG Science College, and then there was options like Dr. and Professor Salvi has told to go either in medicine or in engineering. But I believe in creativity, I believe in invention, I believe in little science and science equation. So I decided to go for engineering. At that time, after the 11th standard, we had a 6-year program. First, we have to do pre-science, that is common science college. Then there were 5-year engineering, 10 semesters. So first 4 years was a common for all the students. Either civil engineering, EC, IC, mechanical, textile was there, chemical was there, clinical type. And then at the end of the 4th semester, you have to decide. So my father told me, my father was a truck driver. He told me, you can choose the line which you like, in which you have got an interest, you go for it. Then, with my own brainstorming, I want to become an entrepreneur. And if I choose a mechanical engineering, then we don't have that money to create a factory or a industry. Similarly, or EC or IC, there are good scope or a computer for abroad. And I don't want to go to abroad as I am alone. I have 5 sisters. So I have responsibility of all my 5 sisters. Then I found that the civil engineering is among all the engineering subjects where I have much more opportunity to being a small contractor, to a chief engineer, or to a real estate tycoon, or anything. So I decided to join the civil engineering. As Professor Sanghvi says, in our colleges there was much academics has not been learned. Only the principle I learn and then I go for fun. I had a great time fighting elections and doing. We are from the Navnirman batch. If you know, there was a huge agitation against the price rise, against the Chinamak government. At that time, we 15-20 civil engineering students started that movement. So we had a good fun at NV College of Engineering. But I decided in my pre-science or in engineering, the other students were from English medium. So I found I should start with learning English, not common but advanced in English. So I joined number of the courses parallel, either at Simcom Corporation or some Rotary Club. So I decided I have to enhance my knowledge. And for that, in each vacation, I was doing number of the peripheral programs and courses. It may be a 10 lectures or a one-day program. It may be related to management, it may be related to engineering, it may be related to some other discipline. Then I was with Avda. Then I started my real estate company. But before that, then I was doing a job at Avda, parallel in the morning 8 to 10. I took a small project of some 20,000 rupees, constructing one room kitchen on a first floor of a tenant. So I decided I want to learn the construction technology on one part. Then I decided at that time, I'm talking about the 77, 78. At that time, the architectural faculty was not, or specialization was not that much popular among the society. Only there was two architectural colleges. That was MS University, Baroda and SAT. And they were producing only 40 or 60 architects per year in Gujarat. Today, I think, in vicinity of Ahmedabad only there are more than 12 architectural colleges. So at that time, the civil engineer, if you talk about a civil engineer, who is the first civil engineer? Who has constructed the pyramid? So he is an excellent material engineer who decided the material which should be long lasting. He was an excellent structural engineer also. There was no architect, so he was also an aesthetic purpose, he was an architect also. So for civil engineer, first my advice is, you should have all the knowledge of all the subject of built environment. So in civil engineering, construction, project management, structure, you should know. You don't want to become a structural engineer, even though you should know that. Similarly, you have to start something your own, but after what duration? So I started first by 6 months as a construction supervisor on Pashura development. Then I switched myself to one of the architects from Mumbai. I had some 11 months with an architectural firm. So where I had aptitude to appreciate architecture at least. Third, one of my friends was working during those days, VMS, who designed our Patanjali, our iconic Ahmedabad building. So sometime I came to VMS where one of my friends was serving, and I tried to learn, other than the BCV which I have already gained, I tried to learn something about structure. Then I also decided, if you construct a building, then functionality of a building, use of the building, utility of the building is also very much important. So I started at least 6 months as an intern for an interior designer. If you know Mr. Surendra Patel, who runs the Vishara. So he was an excellent interior designer during those days. So after doing all that thing, I feel we are still developing. We have a number of the bottlenecks in bylaws, various laws and other things. I should join government. Then I joined the town planning department, government of Gujarat. It is interesting. The salary of Professor Sarvi was something 3,300. My salary was 585 rupees. So, first my lesson is, after becoming a civil engineer, you should explore other peripheral subjects which is related to built environment. It may be structural engineering, construction project management, architecture, something about town planning, all that. Now, secondly, I call myself right now as a leading urban designer, urban planner. My expertise is in urban housing and urban planning. I was director with Indian Institute of Town Planners. This is the institute, Apex Institute, like we had a Chartered Account Institute of India. This is the institute where more than 8,000 qualified town planners. Who can be the qualified town planner? Bachelors in engineering, civil engineering particularly, and architecture. Then you have to do a 2 years full-time master's program in urban planning. In Ahmedabad, there is a NIRMA runs only the Bachelor of Planning program. SEPT runs only the Master of Planning program. So, as a civil engineer, compared to all other engineering disciplines, you had a huge sub-themes and sub-area. You can be a site engineer, you can be a good construction engineer, you can be a good cost accountancy and tenderer, you can be a government officer where you are doing public road engineering in number of the departments. You can join as an infrastructure engineer with data project like metro or cross, like that. But similarly, there are huge, you can be a valuer. It's a good practice. Here I can see out of 110 civil engineering students, at least 20 female students are there. During our time, when we were studying in LP engineering, so 120 in 2 divisions, there are only 2 female students. So, being a female, having a household boss has to be attained by you. You must be interested in some formal job. And in that case, the town planning, valuations, these are the other things where you can work from home and you will be in safe and secure office environment. Here I will little advocate about my profession, that is town planning. Why? Today India is about 125 crore population. Out of 125 crore population, 30% is urban. When we got independence in 1947, at that time only 12% were urban and the remaining portion was a rural population. So there is a global, you can say, very high increase in the urban population. A rich farmer's son will not do farming at his native and he will come to our, he will migrate to other areas. So by 2030, out of 2 Indian citizens, 1 Indian citizen will be urban. So there is a huge career scope in coming 10-20 years in a civil engineering field, in a town planning field, but related to urban areas. If you have heard our our finance minister speech in last budget, he has given emphasis on urban planning, urban infrastructure, urban transportation, urban sustainability, urban housing. So in that case, I see, particularly for you young people, those who want to pursue the masters, there are great scope in a town plan. Actually, as per the 74th constitutional amendment, each town having a population of more than 10,000 should have a qualified town planner on their payroll. But if you see, there is no town planner in Mehsana Nagar Palika, or in Anand, or in any other town having a population 1 lakh, 2 lakh, 3 lakhs. So there is a huge 1.5 lakh urban planners are required. So those who are orientation for doing a safe and secure job, this is one portion. You might not be knowing, so I found that I should share this piece of information to you. Third thing, as Professor Sanghvi also said, after becoming a civil engineer, when you are settled after 3, 4, 7 years, civil engineer is a profession. Your birth is in a hospital which has been constructed by us. Your port is constructed by us. Your railway station, railway track. You are getting the Nabda water. So all is only and only due to the detailed implementation by a group of or by a thousands of civil engineers. So to carry that legacy, you should be very innovative. You should upgrade your knowledge. When we started in early engineering, right, we don't have a computer engineering. There was only one computer in IIM Ahmedabad. Can you guess somebody what is the size of that computer? I'm talking about 1975.
Full size room.
Full size room, got it. So it was a full size room computer, right? So in those days we were studying. But today I can run a structural program of SCAD on my PC. I can do any other things on computer. So how it can be possible? Each time, each day when I find a time, I upgrade myself. So knowledge upgradation is one of the important things. For first 4 or 5 years, you will feel that, oh, it doesn't matter much, but it's not so. It will matter, definitely. So you have to start after graduating, attending and gaining knowledge through various sources. Now, second thing is about a social service of civil engineers. Here I will tell you, in 2001 earthquake, I am actively involved with the Gujarat Institute of Civil Engineers and Architects. So in 2001, on 26 January, the earthquake was in the morning of around 9 o'clock. And people, few buildings collapsed. Few buildings had a great repair required. But that was a trauma. People were afraid. All came out from their bungalow or apartment. So at that time, as an institute, as a civil engineer, we decided all buildings are not unsafe. So let's go, pursue the people, what type of repairing and other things are required. So during those days, we make a team, where there is one is a construction engineer, one structural engineer, one architect, and one another senior engineer. And we visited more than 600 to 700 buildings. So all that 15-20 days, I start my job at 7 o'clock. At that time, I was already a real estate developer. I don't need such things. But I feel that it is my, as a civil engineer, this is my duty. If there is some tsunami or earthquake, or like in Ukraine, the whole city has been destroyed. So at that time, there is a special duty. So in your lifespan or in your lifespan of 40, 50 years of civil engineering, if something happens, you should do it. Finally, I will tell about real estate. I was not from a very big family. healthy family. Even I decided to become a real estate, and today we are constructing more than 50 lakh square feet in Ahmedabad in various places. So what is the reason? Or how I became a success? So of course, any management guru will say your focus, your hard work, right? But only that does not work. Your passion to behave and your professional approach to the business. So passion and professional approach, which has made me at this stage. So any dream is not a big dream or a small dream. You can do the things. If you see the career of most of the leading real estate company of Ahmedabad, most of them, first 10, it has not been inherited by our family or forefathers. If you talk about Seri, if you talk about my company, Sun, if you talk about Navnirma, Prerna, all are the civil engineer, most of them. At that time, there were no engineering college, only there were 4 engineering colleges. One was MS University, second ND, third was ND, and fourth was a Modasa Engineering College. So, you should have, my last tips, these important skills. One is a creativity and flexibility. So you go for achieving your goal, you must have creativity. But sometimes in structure design, instead of going RCC, you have to go for a prefab or you have to go for a steel structure. So flexibility is one of the things. Second is communication skills. Generally, not only the civil engineer, all of we technocrats are very weak. We cannot communicate properly. So this I have found from that day to till today. When I call an interview of a civil engineer for my company, but they cannot communicate or they cannot present. Sometimes we feel School of Building Science and Technology, SAP University students are greater than U1 students. No, I don't believe. I don't believe. But only the campus teaches them the communication skills and the presentation skills. So particularly civil engineers are weak. So how? You try to write a 2-page, a small project report. But what is the aims? What are your objectives? What will be your methodology? What is your research question? And finally, how you are concluding. So this is the second thing. Third, of course, the technical skill is required, and you have to, during your whole lifespan of civil engineering profession, you have to upgrade. Fourth is a project management skill. Now, civil engineer has to work with number of other disciplines. When I was constructing, KT Hospital has been constructed by me. I was a contractor. I was procuring material. I was advising the architect not to do visual or additional things. I was advising my structural engineer. I was advising my HVAC consultant, fire consultant, ELV consultant, electrical consultant. So how I can do that? So I have to tackle number of the disciplines, and in that case, there are a number of the methods, like the CPM, part, these, that. You should know the project management. Right now, your intake is at very junior level. But when you want to go out, or you want to become a real estate developer, even the project management has been handled by us. We know what is the finance. We know what are the radar deadlines. We know what is the quality. So all that thing has to be done. So project management, and finally critical thinking. As I initially told, why I choose civil engineering or engineering. So basically, I was much interested in innovation. I was much interested in science. I was much interested in applied mechanics and all that subjects. And that took me. So in that case, a critical thinking. What will be the material after 10 years? What will be the material after 20 years? So all that thing has to be done. So best of luck and thank you very much. Thank you.
So thank you, sir, for giving us the motivational speech and whole your journey. And we have also our another guest who is with us. So she is Mrs. Sangeeta Kapoor, who is with us, and she is founder and director of Blue Planet NGO. She has been actively working towards creating awareness and capacity building through education in implementation of sustainable design for collective since 2015, and she is also famous for her work with bamboo structure. So let's a round of applause for her. So thank you ma'am for giving your time. And now what we have made here for our today's lecture number 4. So in transit concrete by Engineer Keval Asad. So please go back, and I will request our own dignitaries and guest of honors to join us for this session. Thank you, sir.
So, we'll be starting now. A very good evening to everyone present here. And I have already been introduced by my colleague, Mr. Mukesh Mistry. So, I would be introducing myself. Let's get to the subject. So, I'll be talking about in-transit concrete for today. And my name is Keval Asad, as you can see on the screen. Let us look at the photo. I believe in photography. So, what do you interpret from this photo? Can anybody tell me? Anything? What do you interpret from this photo? Based concrete, okay. Anything else? Homogeneous mix, okay. Fine. That is great. So, yes, flowable concrete, okay. So, can anybody of you tell me whether this is a site mix concrete or a ready mix concrete? Ready mix. कोई site mix के लिए anybody? No? Fine. So, just a simple note. Whether this is a site mix concrete or a ready mix concrete, I also do not know about it. See, it is very simple. There is no rocket science about it. If it is made on site, it is site-made concrete. If it is prepared at an RMC, a ready-mix plant, then it is ready-mix concrete. और तुमको मतलब आप लोगों को पता कैसे चलेगा? How will you know? तुम साइट पे होगे तो पता चलेगा. So there is no rocket science, as I have already told you, and this is just concrete. So getting to the next slide. Before we go to the next slide, can anybody tell me what is concrete? Basic question, very basic question. Yes. Thank you so much. I have already orchestrated all this in the previous lectures. So basically the word concrete comes from Latin. It is a Latin word called concresto, where con means together and cresto means to grow. So this is where the word concrete comes from. So already you have defined concrete. Let me define concrete for you. Can we say that concrete is something where cement plus water prepares a paste, and this paste surrounds all the aggregates which are present in the mix and binds them together. Is that concrete? Yes?
Yes.
So you don't simply say yes or no because I am on the stage. Yes? Yes? Yes. So let us take this theory that there is concrete, right? Then in this definition lies the key to concrete. Concrete is the only substance on earth which can flow in its state where it hasn't hardened, and as soon as it hardens, it becomes strong and durable, just like me. So there is nothing to laugh about it. It has become strong and durable. So that is concrete for me. Accepted? Fine. So the cement paste plays a very important role in concrete. Wherever there is cement paste is more in concrete. So what will happen to the concrete? If cement paste is more, then the concrete will dry and there are chances of cracks. Yeah? True? Because of the more cement paste. If the cement paste is less, then what happens to the concrete? The concrete will remain porous. Yeah? Or you can say it will cause honeycombing in the structure. So in both the cases, durability will be affected. Concrete nowadays is just not about the strength. It is about the durability, what we have as civil engineers want to bring out from concrete. Accepted? Yes. So I can only hear one person saying yes. That is all right. That does not mean this water cement this cement paste basically depends on the water cement ratio in the concrete. If the water cement ratio is high, the strength will decrease, also will the durability. If the water cement ratio is low, then the strength will increase, but it will not be workable on site. So there comes the role of admixtures, when you put in admixtures and the concrete becomes workable at site. Yeah, so all these theories have already been told in the previous lectures. I just wanted to convey the message that if cement paste surrounds the aggregates and it binds them together, then that is also concrete. Yes, true. So let me go to the next photo. As I said, I like photography. So what do you think about this photo? Or there is a very important, famous phrase behind it. Roman path, yes. So all roads lead to Rome. Yeah. So Romans were the first engineers who built pathways, or I would say roads, and also they are famous for one more thing. So they are also famous for this. Can you tell me what is this? Yes, someone said. It is an aqueduct. Yes, true. There is another famous saying. What is it? That necessity is the mother of all inventions. True? So necessity theme, then they invented the roads. They invented the roads because their soldiers as well as the persons, the citizens living in Rome wanted a safe passage for them to pass from one place to other place. There was a second necessity. During their time, water was not abundantly available to them in Rome. So they searched for a source of water and they had to bring that water to Rome. That is why they built aqueducts. These aqueducts are still visible in Rome. They were built somewhere around 312 BC. Okay, BC stands for before Christ. So they were built around 312 BC. They are 16 kilometers in length, and there is a magnificent engineering marvel. Why is it a magnificent engineering marvel? We'll see in the next slide. There is one more saying, what Romans used to say, that if you want something to last, make it out of concrete. Okay. Fine. So I hope I am not boring you all. No one is responding. Okay, fine. So the Romans were the first ones to make concrete. They made concrete out of brick dust, broken bricks and lime putty, and somewhat volcanic ash they used to find in Rome. So these roads and these aqueducts were called Appian roads, or Appian ways and Appian aqueducts. A simple aqueduct, what you can see on the screen, this is the water source, and this is where they used to distribute their water. This is the aqueduct, this is the siphon. This technology at that time, I guess it would be impossible to build. they have also built shafts, surveying shafts where they can repair their conduits or they can go inside and clean. So this was something the inside of this shafts looked like. This was what the top of this aqueducts looked like. And the engineering marvel which I was talking about, there were no pumps at that time. So how could water come from one place to other place? Gravity, exactly. There was only a 10-meter difference in the level between the 2 points, and water could flow from one point to other point. It is 16 kilometers in. So that is an engineering marvel. It is still in existence in Rome. If you visit Rome sometimes, please go to this place. There comes, after the Romans, somewhere this concrete we had lost in time, because the Roman civilization built many things like the Colosseum and various other structures out of this concrete. But the Roman civilization declined, it went away, and we lost somewhere concrete in time. Then this concrete development came because of the development in cement. So cement technology developed as well as the concrete technology developed. So this cement technology development is, I have just made a timeline. In 1774, a person named John Smeaton created something out of lime and other materials, and he said he would bind all things together. Then in 1812, there is Louis Vicat from France. He invented hydraulic lime. Why am I stating all this? Because these points are important in knowing how concrete evolved as a product. In 1860, the world's first unreinforced bridge was built in France. And in 1824, as in the previous lectures you would have known, that Mr. Joseph Aspidin, he patented Portland cement, what we have cement in today's world. Right in the next year, in America, there was an canal named Erie Canal, which was built out of concrete. This is the first structure built out of something what we call modern concrete. Okay. This is an important portion, just wanted to highlight. In 1902, an architect named August Ferret, he designed and built a building, which the photo is attached here with, in 1902, and this building was based on the subject of columns, beams, what we call frame structure in today's world. And from that part, the load-bearing structures were declining. I mean, इसके बाद जो ये इन्वेंशन हुआ उसके बाद लोड बेयरिंग स्ट्रक्चर्स का डिक्लाइन आने लग गया और हम फ्रेम स्ट्रक्चर की तरफ बढ़ गए. Moving on, in 1903, ready-mix concrete was patented by an architect. And why am I exclaiming? Because architects have very little to do with concrete. But still, RMC was first patented by a German architect named Jules Heinrich Megens in 1903. He developed the concept of an off-site concrete being made off-site. But he could not develop the concept of transporting this concrete from off-site to site because of the lack in the development of automobile engineering or automobile technology. Right? We move forward. Can anybody guess who this gentleman is? Nobody? Fine. Can you tell me who discovered the bulb? Yeah? Anybody one? Thomas Alva Edison? Okay. So this is Mr. Thomas Edison. So he was also a very famous inventor. He in his times had invented many things, not only bulb. So he had made 11 buildings out of only concrete at that time. Please carefully listen to me. Only concrete at that time, which are still in existence in New Jersey, USA. At that time, nobody used to build a whole building out of only concrete. And this building still exists in New Jersey. And they are named after him also. He created a 1 mile road of concrete road in New Jersey again. Till today, till to the technology, Ahmedabad Municipal Corporation or Ahmedabad has not accepted and they just accepted the importance of CC road. So So you can see what was the visualization of this map, what we are talking about. Right. This was 1908. This was the first machine which carried concrete. Right. So actually ready-mix concrete was first developed in somewhere in 1913 in Baltimore, USA, where it was processed in the central plant and concrete was carried through this wagon. Right. In 1977, transit mixers are machines which carry concrete from one point to the other point. In 1927, it was the first time when a Paris transit mixer was developed. It was an horizontal type mixer. You could mix concrete in it and could transport concrete in it. Also, the Airy Steel Company developed something of a dry mixer which could weigh, that means it could measure and distribute all the particles in concrete, that is aggregate, cement, etc. So at that time there were two types of concrete mixers. There was one mixer which was a dry concrete mixer and the other was a wet concrete mixer. Dry concrete mixers are mixers where dry material is put in the transit mixer along with water and the transit mixer mixes the mix. Whereas the wet ones are the ones where there is a central mixer in which all the materials are put and they are mixed in the plant itself. The transit mixer only transports them from one place to the other place. So in 1927 they could do it. This was sort of an first transit mixer, a horizontal type. Moving on, the technology developed. This was the first time of a plant, the RMC dry mix plant, which was developed. At this time, there was a technological war between the USA and UK, the Great Britain at this time. So they both were in war of developing these mixers as well as these transporting vehicles. From 1930 to 1950, because of the World War, there was a less development in the technology of these concrete mixers or what you say the transit mixers. Still, some of them developed further. This was some of the photographs. You see the dump truck, the directly the waste is dumped in the truck and water is added and you can mix concrete and take to your site. The automobile engineering, the automobile field also saw technological development. Moving on, this was somewhat a photo I wanted to share that how they used the transit mixer, the horizontal mixer to do concrete. This is in 1960s some sort of a modern transit mixer which you see nowadays, but still the technology was not sufficient enough to carry the load of 6 meter cubes of concrete which it does do. This timeline is very important. Let us look at this timeline of development of this ready-mix concrete. I would not say ready-mix concrete, I would say concrete itself. In 1930, air entraining agents were developed in America. These air entraining agents were developed to increase the workability of your mix. In 1935, Hoover Dam was built in America. Again, in 1942, the Grand Poly Dam was built. In 1950, decorative concrete was developed in America. 1950, decorative concrete at that time mean color concrete. You put a pigment in the concrete and that becomes your decorative concrete at that time. In 1970, fiber reinforced concrete was introduced because there was mass construction going on everywhere, and mass construction always leads to cracks in the structure. So this fiber reinforced concrete was introduced at that time. In 1973, somewhere Sydney Opera House was built. Have you seen the Sydney Opera House?
Yes.
What is the shape?
Lotus.
Yes, lotus. So you can imagine at that time with concrete how could they have constructed this Sydney Opera House. Self-compacting concrete was developed somewhere in 1980. We'll go to the history of self-compacting concrete in the further sites as we go forward. In 1992, somewhere the commercialization of RMC plants was done in India. RMC was used in India from 1950, but at project sites, only at project sites like the Bhakra-Nangal Dam or other mass projects. It was not commercially available to people. In 1992 somewhere we set up the first plant in Pune which provided commercial concrete to people, and therefrom there is no looking back to India in the history of RMC. Also a 65-story building was developed in Chicago in the same year. Burj Khalifa 2011, SOU 2018, and in between this there was a palm tree structure built in Dubai. Palm Jumeirah, correct. So Palm Jumeirah, a fact figure, Palm Jumeirah is the only man-made thing that can be seen from the orbit after. No. So after the pyramids in Egypt. So it is the only thing that can be seen from orbit which is man-made and which we have used concrete after the pyramids. So I hope everyone is with me because no one is answering. So please be with me. So this is somewhat a modern RMC plant which it looks like. The next slide is a video. Video shows about various RMC plants used nowadays at site. It is taken from a company called Enix. So I will request you to please watch this video. Then we will discuss about somewhat the modern RMC plants.
There are many classification standards for concrete plants. Concrete plant can be divided into the stationary concrete plant and mobile concrete plant depending on whether it can be movable. It can be also divided into dry mix plants and wet mixing plants depending on whether a central mixer is used. Stationary concrete plant. The stationary concrete plant is designed to produce high-quality concrete. It has the advantages of large output, high efficiency, high stability, and high specification. Stationary concrete batching plant adopts reliable and flexible. It is easy to maintain and own a low failure rate. It is widely used in various projects such as roads and bridges, ports, tunnels, dams, and buildings. Mobile concrete plant. The mobile batch plant, also known as a portable concrete plant, is a very productive, reliable, and cost-effective piece of equipment to produce batches of concrete. It allows the user to batch concrete at most any location, then move to another location and batch concrete. Portable plants are the best choice for temporary site projects or even stationary locations where the equipment height is a factor or the required production rate is lower. Dry mix concrete plant. A dry mix concrete plant, also known as transit mix plant, weighs sand, gravel, and cement in weight factors via digital or manual scales. All the ingredients then are discharged into a chute which discharges into a truck. Meanwhile, water is either being weighed or volumetrically metered and discharged through the same charging chute into the mixer truck. These ingredients are then mixed for a minimum of 70 to 100 revolutions during transportation to the job site. Wet mix concrete plant. In a wet mix concrete plant, the concrete is mixed at a single point and then simply agitated on the way to the job site. To prevent setting, using agitators or ready-mix trucks or hauled to the job site in an open-body dump truck. Dry mix differs from wet mix plants in that wet mix contains a central mixer, whereas dry, which can offer a more consistent mixture in a shorter time, generally 5 minutes or less.
Okay, so this was the video showing various different types of modern RMC plants. Generally, this stationary RMC plants are placed at precast units where they require more quantity of concrete. Their capacity ranges from 60 cubic meter to 205 cubic meters per hour. Okay, so there are the stationary plants. The next are the mobile plants. The mobile plants are generally placed by companies at sites where they can move from one side to the other side, and the capacity ranges from somewhere around 30 cubic meters to 120 cubic meters per hour. Okay, so there is a third type of plant which could not be described here, which is a self-weighing plant. On a transit mixer, a weight puller is provided, where aggregates, sand, cement are put, and it automatically weighs and mixes the concrete at the site only, but their capacities are very low, and they are from 2 to 4 cubic meters in capacity. So this is the main component of an RMC plant. Besides this, there is a laboratory where all tests are performed, like the compression test, all the mechanical tests are performed. But there is also a chiller plant. In this weather, where there is a hot weather concreting is to be done, then ice flakes are used in concrete. So a chiller plant is also provided at a site or at a RMC plant location. And there is another thing which describes the sustainability which concrete needs nowadays. It is the recycler plant. Recycler plant is nothing but if some concrete is left in the transit mixer, it comes back to the plant. The left concrete is put in the recycler, water is flown. If water flows, then the aggregates, the sand, they are separated. They are taken back as aggregates and sand and used again in the concrete. Yes, segregate, exactly. So this is the recycler plant. Also for sustainability, if there is an old building which is taken down and debris are there, then these debris are broken down into small pieces and used as aggregates as a recycle. So this sustainability portion where it comes to RMC, these are the things which are used. So this was a brief description about an RMC plant. Okay. So can you tell me what is this? What is this that you can see on the screen? Come on, yeah, you all are Generation Z. You like LOLs and whatever you say. So ये क्या है? Louder, ma'am, louder. Wait, but why? Nobody questioned me. All of you are sitting here. Nobody questioned me. But why this technological development is necessary? Why it is required? Romans used to do concrete like this. तो हम क्यों नहीं कर सकते अभी भी ऐसे? Why is this technological advancement required? So I will tell you. First is necessity. As I have already mentioned, that necessity is the mother of all inventions. So necessity है तो invent किया, आगे बढ़ गए. For the second reason, I am going to go for a photograph, a very interesting thing. Who is this? It was something around 2008 when he looked like. Who is this? Yeah, this photo is from when? It's from something around 2018. So, in 2008, he was an under-19 Indian cricket team captain who had won the World Cup. He was selected for the IPL. In the very next year, he was also selected for the Indian cricket team. So, can you guess? Can you see the difference? What is the difference between the two photographs? Age. Oh, age is very good, but I wanted something different. Yes, somebody said very loudly. Soberness. No, not soberness. Fitness. Correct. Fitness. So, why was it required? In 2008 also he was very successful. So, why did he add this fitness to his regime?
Field perfection.
What?
Field perfection.
Field perfection. Okay, I want something else. Performance. Okay, ma'am. Yeah. True. This is called value addition. Anything, any human being, any material, any company wants to add some value to it. How could Virat Kohli add value to him? By becoming fitter. Yeah. So he became fit. All the world champions champion athletes were fitter than him at that time. But after this 2018, he is considered as the most fit cricketer in the world. So this added value to him. There is another example of adding value to something. Then in 2003 somewhere, the England cycling team appointed Dr. Dan as their performance coach. Why? Because the British team in the last 67 years, past 2003, had only won a single gold medal at the Olympic Games. And do you know something about Tour de France in cycling?
Yes, sir.
Yeah, what is it?
The longest cycling route.
Longest cycling route? Okay, I want something else. It is the best cycling race. I guess it is the championship of cycling. Yeah? Okay. So, in 111 years from 2003, they had won no Tour de France championships. None. Zero. It was such a pathetic condition that one of the most famous European cycling brand did not want to sell them their cycles because they thought if the Britishers use our cycles and the other professionals won't be using our cycles and our sale would go down. So that at that time they had appointed Dr. Dan as their performance coach, and his theory was gain of marginal gains in every point of process you do. So his theory was named the theory of marginal gains. It is very simple. Have you done differentiation in your class 11 or 12?
Yes, sir.
What is differentiation? No, that is the formula, my friend. Differentiation is breaking something into small parts, then calculating. And what is integration? Summation of all. So when you differentiate a process into various parts and improve on every part by 1% at a time, then this integration will go up to, there is no point that what it will go up to. You cannot define the point. So his team started breaking up the process. In breaking up the process, in everything they wanted 1% improvement. So what they did, I am just naming the processes, some of which I know. The team, the seat hota hai, the seat on which they sit, they changed the seat to more comfortable seats. They applied some oil on the rubber of the tire for better gripping. They aerodynamically checked their shorts, the shorts which they wear, and they recommended their outdoor performance to wear indoor shorts because they were aerodynamically more better. So यार मेरे साथ रहो, मैं जो रुक जाता हूँ तो मेरे साथ मत रुक जाओ. Please continue with me. So moreover, they went to such a phase where they had appointed a surgeon to teach their athletes how to wash their hands. Why? Because they would catch cold, and they did not want them to catch cold. So another thing which they did for muscle relaxers, there are some gels used, which you can your muscles will relax. So they use different gels for that. Okay. In fact, the pillow and the mattresses which the athletes used to sleep were changed for better sleep results. And they went to such a level, they used to store their bicycles in a place, and they colored the interior of their place white. So why did they do that? Because the fine-tuned bicycles were kept there. And if a single point of dirt would sit on their fine-tuned bicycles, then the performance would be effective. So they went up to this margin, and within 5 years of all this improvement, there was such a radical change in the bicycle team that we cannot imagine about. In the 2008 Olympics, they won around 60% of the gold medals available in the bicycle category. In 2012, they created 9 world records and 7 Olympic records. In the same year, one of their athletes won the Tour de France. A year after the 2012 Olympics, consecutively for 4 years, they won the Tour de France. So, summing up, if you calculate their medal tally from 2007 to 2017, they had 178 world championships to the name, 66 gold medals in Olympics and Paralympics games. Also, 5 Tour de France championships to the name. So within a span of all these years, cumulatively getting all this, adding value to the sports, they did this. So adding value is very important. So I have said many things about adding value. Let's come to concrete now. So there is a manufacturing process to concrete. Can anybody tell me there are steps in manufacturing of concrete? Steps in manufacturing of concrete.
Target which?
Yes?
Target.
No. I mean, when you are patching the concrete, there are steps. Have you gone through your books of concrete technology? Yeah? So tell me, what is the manufacturing process? Yes, mixing. Mixing के पहले क्या आएगा? Mining? Patching फिर? Mixing फिर? वहीं पे डंप कर दोगे? Transporting, then? Placing, then? Compacting, then? Curing, and finishing. So how many stages are there? 7. Now can you imagine RMC has covered the first 5 stages of this manufacturing process?
Yes, sir.
How? अरे प्लेसिंग तब आरएमसी तुमको मदद करेगा. Pumps होते हैं आरएमसी प्लांट के पास. There are pumps with RMC plant. The concrete comes, they are put in the pump, and the pump places the concrete where you want to place it. So the 5 things which are important in manufacturing process have already been covered by the RMC plant. In fact, the technology has grown so much that even the 2 steps which are remaining are also being covered by concrete somewhere, somewhat, and we'll be talking about it. So, if value addition, all this value addition, why I am talking about? Because there are value-added concretes. If there is a simple concrete and you add something to it, it gives value to the concrete, and it is called value-added concrete. So we'll be talking about the value-added concrete. So what do you see in this photograph? See, I am a photographer, so I like photographs. So what do you see in this photograph? Okay, just tell me, what are the material used for this flooring? Tiles. So, anything else? No, my friends, this is stamped concrete. So this is a type of value-added concrete. It is called stamped concrete. Stamped concrete. It is also a part of decorative and colored concrete. Okay? Right. So where stamped concretes are used? Stamped concretes are used on garden pathways, on cycling paths, or on parking tracks, alleys, etc., etc. And this kind of style are available in stamped concrete. This is most advantage of this stamped concrete. We'll talk about it. So these are the uses: landscape, jogging tracks, garden peripheries, podiums, atriums, etc., etc. What are the advantages of this stamped concrete? Customizable design. You can customize the design of your concrete as you like. You know, when you go to eat ice cream, you say you put 1 scoop of chocolate, 1 scoop of strawberry, and 1 scoop of vanilla, and then give it to me. So what is that? Customization. So you can customize your concrete, your design as per your requirement. Strong, durable, and low maintenance. As you know, one of my friend here said that the photo had tiles in it. But if you use tiles in all these places, they are not durable. They are not strong enough to withstand the vehicular loads. Also, their maintenance is very high. Rather than this stamped concrete, maintenance is only one thing, that you have to clean it periodically. Ease and safe pedestrian movement, a very easy movement for pedestrians. Prevents growth of weeds. If you use any other material, there will be growth of weeds from the underground, because there is a layer of sand on which this wall will be placed, and because of which winds are possible, and no settlements. Also, if you use tiles or other material, there will be settlement, but if you use this concrete, there will be no settlement. So, what are its properties? So, its properties are, if it is used as a pedestrian jogging cycling track, a minimum of M25 grade and 75 mm thick. If there is light vehicular traffic, then minimum of M25 or 30 grade and 100 mm thick. Heavy vehicular traffic, M30 minimum and 150 mm thick. So 150 mm thick would always be a road. So this is very likely used, or it is generally used in this pedestrian and jogging cycling track section. Okay, so this was stamped concrete. Moving on. So as civil engineers, we will face this kind of structures at site. So concrete, if you place concrete, concrete will be placed. But how will you compact the concrete you have placed?
Vibrator.
Vibrator? I don't think the vibrator will go inside.
Self-compacting concrete.
Okay. So you all know about it. So this will be concreted with the self-compacting concrete. Self-compacting concrete is a specialty concrete. We will know about this from this video. So let us look at this video. It is a mute video and I will be talking with you about self-compacting concrete. Self-compacting concrete was developed in 1980 in Japan, because at that time there was shortage of manpower with Japan and they wanted to develop, and development also always means infrastructure development. I know you all are interested in the video. Video में form बना है and only one person is concreting. The concrete is being poured, and you will slowly see that the whole foam will fill up with concrete. So I was on this history of self-compacting concrete. It was developed in Japan, and while it was developed, they used maximum fines, that is fine aggregates in the concrete, along with viscosity modifying agents and admixtures. But since technology has developed in admixtures also, high PEC based, the polycarboxylic ethers, are used in self-compacting concrete nowadays, which provide the properties of VMA to the concrete. Right? So it will flow by itself. Only one man is required to do the concreting. No compaction required. There is no compaction required for this concrete. So what this concrete does actually, manpower becomes minimum, no compaction required. The flow of concrete is such that the whole foam will get filled up, and because of this the fine aggregates, the filling of the foam will, the density of filling of the foam will be very high, hence the finishing will be excellent. So as you can see, it's still going on pouring, and the concrete is flowing. This is a kind of a video which shows. I'll just let you see the video now. क्योंकि मैं बोल रहा हूँ तो आप लोग मुझे नहीं सुन पा रहे हो और वीडियो नहीं देख पा रहे हो, तो I'll just let you see the video. See, again, only one person is required, and the foam is filling slowly. Fast work can be done with SCC. High finishing concrete can be achieved with SCC. Less manpower required and less cost. Obviously, the cost of admixtures will be there, but since the manpower required is less, the cost goes low. The slump of this concrete is around 550 to 750 millimeters. And there were European standards for this concrete. Now India has also started developing codes for this concrete. So you can see this will be filled by itself. to every nook and corner of the foam, the concrete has reached. Okay, so I'll go to the properties. Let's skip this part. Okay, so these are the uses of self-compacting concrete. As I have already discussed, its advantages: free-flowing, self-compacting. It does not require any manpower खींचने के लिए to bore it up. It is self-compacting, easier placement of concrete. Again, you do not require any manpower, no vibrations required. Superior surface finish, already discussed, because of the fines in the concrete. Denser microstructure, again because of the fines in the concrete, and somewhere when these aggregates are used and this aggregation is done because it has to be picked. तो इसको पिकिंग ऐसा होता है कि एकदम डेंस मटेरियल बनता है जब हम एग्रीगेट सिलेक्ट करते हैं. तो फास्टर कंस्ट्रक्शन एंड फ्यूअल लेबर रिक्वायर्ड. दिस आर द extravagant points, technical points. That is some flow is around 550 to 750 million. Okay. Again a video. See, I have already said that I am very fond of videos. So just look at this video. There is no Mangal Jadugar here. So where is the water going? Porosity. Okay. So that transit mixture is around 6 cubic meters. All the water has been absorbed by the layer. So this is pervious. Sorry. So this is pervious concrete. Pervious concrete properties. It is generally used where sustainability is required in the project. Generally on places where there are walkways, there are pedestrian ways, there are cycling ways. What happens? Okay, water falls on this pervious concrete and it is porous because usage of only coarse aggregates in this type of concrete. Due to this porosity, the water flows to the under layer and water is absorbed. Generally when concrete is cast on roads, why it is avoided? Because the water which falls on it, it does not go to the subsurface, it flows away. This flowing away can cause many problems to the natural phenomenon in which we live. Hence this concrete has been developed. Its density is around 1600 kg per cubic meter to 2000 or somewhere around 1800 kg per cubic meter. Voids of 15 to 25% are present. Flow rate of water is 0.2 to 0.54 centimeter per second, and its compressive strength can go from 3.5 to 28 megapascal. Okay, so we'll move ahead. This was what the present technology looks like. Now what will be the future? So for the future, again a video which we will look into and then discuss about it.
Seems like a short while ago, but the first developments made in the 3D printing of concrete date back 20 years. After successfully printing ceramics, the Contour Crafting Project, University of Southern California, aimed at using concrete to printing larger concrete construction elements. This Dutch team accepted the challenge and started experimenting. The results were rudimentary, but nonetheless, this meant the first important step in the development of the concrete printing technology. 2005 marks the year that Pervious realized the first manually 3D printed wall in one continuous process. It was 3 meters wide and over 2 meters high, and took 2.5 hours to produce. The wall was built using a cart with its wheels and rails that moved from left to right and back. The cart carried a nozzle that distributed the mortar. In 2015, Pervious, professor of the Technical University of Eindhoven, initiated the consortium 3DCP. It marked the introduction of actual 3D printing technology to the previously manual process. Things started moving fast from there. The combined knowledge of BAM, Pervious, and TU Eindhoven led to the development of parametric computer models, optimized mortar mixes, and printing robots. Shortly after, 2017. This resulted in the world's first 3D printed concrete bridge. This 8-meter-long engineering feat was placed in Hager, the Netherlands, and was extensively covered by media across the globe. No more than a year later, the equally newsworthy milestone housing project was revealed. A series of 3D printed houses in Eindhoven. With this, a whole realm of new possibilities opened up for the 3D printing market. Another big milestone followed in 2019, when Bob and Pervious opened the first industrial and commercial 3D concrete printing facility. Its 2 printing robots are now operational and working on projects on a regular basis. In the meantime, the factory intensifies the digitization of the complete design to realization process. They call this process digital manufacturing. So, what are they actually manufacturing there? One of its more recent projects was the Perfect Wave, a skateboard ramp produced for the Dutch Design Week in Eindhoven, demonstrating how the process creates freedom for designers. Currently, the factory is working on another first-in-the-world project, the longest 3D printed concrete bridge in the world. It stretches an unprecedented 29 meters. This project was commissioned by the Dutch city of Nijmegen and designed by renowned designer Untitled. It consists of separately printed elements which will be assembled on site. A daring and complex project which involves substantial experimenting and testing. 3D concrete printing is not just beneficial for big, audacious projects. For normal, routine jobs, this technology can save substantial amounts of time, cost, and waste. Like the stairs we printed for program, the parametric model allows easy adjustment to each unique situation and is delivered to site as a prefabricated, ready-to-place object, or the formwork of concrete elements for the train station of Driebergen sites. This project resulted in an 80% saving on on-site labor and 60% saving on process time on site at no additional cost. Because concrete is only printed where it's needed for the construction, we're able to vastly reduce the amount of mortar needed. And since there's no more need to make molds or casts, we can minimize waste.
Okay, so this was the process which they showed you what 3D printing, 3D concrete printing is all about. I think along with this ultra high performance concrete, bacterial concrete, this is the future of ready-mix concrete, which will lead us to the final 2 steps of manufacturing, as I said earlier. What were the final 2 steps?
Placing and curing.
Curing and
Finishing.
curing and finishing. This requires minimal of finishing. Okay, the only thing left is curing, and in the next thank you. And in the next lectures, you will come across various products which do not require any curing, and this technology is under still development. If this concrete does not require any curing, so this will be the future of RMC. And as I have said, that all the steps have already been covered, and these 2 steps will be covered in the near future. This concrete, 3D concrete, has strength around 50 to 60 megapascal, and the extrusion process, also the mix design, is on the basis of yield stress. You might have heard of yield stress. So this design is based on yield stress. It has no coarse particle, no coarse aggregates, only fine cement and water. That's all. So that will be all from my side today. What I wanted to help you out with, or wanted to share my knowledge with. Now, any of you are having any questions, then I am open to questions. Yes.
Sir, you said about 3D printing concrete. So there are hollow spaces in between. So what is the resulting durability and strength of the concrete?
So strength of the concrete, mechanical properties have proven that it gives around 50 to 60 megapascal of strength, So strength is not a factor here. And as I have told you, that the design, what they make for 3D printing is based on yield stress. So a lot of calculation goes into it, and it is made in such a way that durability is not affected. Only the hollow portion which we were talking about, it acts as a barrier. You know, sound insulation or other insulation processes can be done if it is kept hollow, and there will be no effect on the strength or durability.
Sir,
Yes.
how much time it will take to commercialize 3D printing in India?
Commercializing 3D printing in India, I think it is a long way to go. They have constructed something with L&T in Kochi. The guys who have developed this technology, they have constructed a 3D printed house in Kochi. But still, the commercialization is very far away from us, I think so. But looking at EOL and the generation Z and the alpha generation which has come through, and the revolutionization in the mobile technology, I think it will take around 5 to 7 years. The 3D printing will be very common in India.
So the foundation of putting will be 3D printing, or it will be placed above that?
No, it will be placed over it. Over it.
Over it.
Yeah. Okay. Anything else if anybody would like to ask? Yes. What? No, it is not time consuming. It's time saving. You can build a single story house in just a matter of 8 hours.
So right now, printing is time consuming. It is said by the designers also.
So it is not time consuming when you know the extrusion process, you have designed the building as well as the mix design. Why they are saying it is time consuming? Because the design, the structural design as well as the concrete mix design it is an iterating process. Iterating process, I mean to say that it has to take many turns before the final design is set up. So that takes time, but the construction process does not take. Okay, so yes, anything you would know, like to know further, you can always contact me on this mail ID. Thank you so much for patiently listening to me, and I hand over the proceedings to Mukesh. Thank you.
So, thank you, dear right. Just a few minutes. So, friends, once again, thank you for listening properly.